Hi there and welcome to our third lesson in our C6 topic all about redox reactions, and today we are going to be looking at oxidation and reduction, which is what a redox reaction is. We'll be looking at some of those and some displacement reactions to see where the redox is actually happening. So I will see you at the end. Bye bye. Okay, so let's have a look at our objectives for this lesson. So by the end of this lesson you should know and understand how oxidation and reduction reactions can be used to protect iron from corrosion. Corrosion, which is also known as rusting, is the formation of hydrated iron 3 oxide. When iron reacts with oxygen and water, it's able to form rust, which is the hydrated iron 3 oxide. Now, iron is an extremely useful material for building homes, factories, and of course oil platforms that can go out at sea. So it's very important that we can prevent them from actually forming this hydrated iron oxide, as it weakens the iron. Now, there are four main ways of actually doing this. The first is very simply covering it with grease or oil that prevents the oxygen and water coming into contact with the iron. However, there are some chemical ways of doing it as well. The first is galvanizing, which coats the iron with zinc. Now, the zinc will react with the oxygen and water, and it will prevent the iron from actually coming into contact with the iron and water, and therefore it remains as the iron or steel rather than the rust. Now, this is a type of sacrificial protection, which we'll talk about in a moment. Tin plating, which coats the iron in with tin. Now, the problem with this is if the tin becomes scratched, then the iron can corrode and the iron can lose electrons. Now, the losing of electrons we'll talk about in terms of redox in a moment. Alloying, which just means adding more and more metals to the iron or steel to change the properties of them. And then finally, there's sacrificial protection, which is what the galvanizing is, where we use a more reactive metal such as magnesium or zinc. Now, that will cause the more reactive metal to lose electrons rather than the iron, so the iron is no longer rusting. Now, we have come across oil rig before, which means oxidation is loss and reduction is gain in terms of the redox reaction. Now, in the case of the iron rusting or corroding, the iron goes from being a normal iron to being a positive ion, which means it has lost electrons, which means it is oxidized. The oxygen gains electrons, so it is reduced, which means that the corrosion reaction we've just seen is an example of an oxidation reaction. So here are a couple of examples of some oxidation reactions, where Fe becomes Fe2+, and we've lost these two electrons. Fe2+ can become Fe3+, plus an electron, and Cl- can become Cl, and again we've lost those electrons. Now, anything here that is oxidized itself can be described as a reducing agent, as whatever it's reacting with, it's gaining electrons. Now, on the reverse side of that, we have reduction reactions where the Fe2+ gains 2 electrons to become Fe or iron. The Fe3+ gains an electron to become Fe2+, and the chlorine molecule gains electrons to become Cl-. Now, because of that, these are described as an oxidizing agent. Now, in a redox reaction, you normally have one thing that is reduced and one thing that is oxidized, making the opposite one an oxidizing agent or a reduction agent. Now, we also mentioned earlier on about the metals in the galvanizing and sacrificial corrosion, where a more reactive metal is often used to prevent iron from rusting. Now this can often give us an idea about displacement reactions, where a more reactive metal will displace a less reactive metal. Now what we're going to have a look at now is some examples of where a metal has reacted or not reacted with a metal salt in a solution. Now if we look at these results, we can see the Y's give an indication of where a reaction has happened, and the N's are a no, there was no reaction. Now where we've got the grey dots or the grey squares is because we've got zinc with zinc chloride, so there will be some sort of equilibrium reaction where the zinc is just replaced by itself. Now from these results we can see that when we look at the metals as they go down here, we can see that the magnesium will displace all three of the other metals, whereas tin does not react in any of them, so does not displace, so it is the least reactive. We can also see that zinc will displace tin and iron in the chlorides, showing that zinc is more reactive than iron and tin. Now you should also be able to construct the formula equations for each of these. So what we'll do is we'll go through those now. So here are our displacement reactions, where we can see magnesium displaces the zinc. Now why this is a redox reaction is because the magnesium loses electrons to become Mg2+ here. So that's losing electrons, so oxidation is lost, so that is oxidized, whereas the zinc is 2+ here and becomes a metal here, so this gains electrons. And we have exactly the same with each of these metals on here as well. Okay, so we need to remember then that oil rig, oxidation is loss of electrons and reduction is gain. So if a metal is going from a metal to an ion, they are losing electrons, so they're being oxidized, whereas if they're going from an ion, so a positively charged ion, to a metal, then they are being reduced as they are gaining electrons. Again, we need to remember about displacement reactions, how to construct those symbol equations, and I think that's it for this one. We will be doing some more redox stuff later on. Anyway, I hope you've enjoyed this, and I'll see you again. Bye bye.